Let's get started on learning a little bit about PySDK. There are three basic components to PySDK. First, we have the inference engine, which allows AI models to perform inferences across different AI accelerators. Next, we have the AI model, which determines what type of inferences are being made, such as detecting objects on screen or making a live transcript of someone talking. And lastly, we have the model zoo, which stores and creates collections of AI models that the inference engine can access and use. To dive a bit deeper into the inference engine, PySDK supports three distinct types of host addresses from which inferences can be run. And these host addresses are AI hub inferences, AI server inferences, or local inferences. The easiest way to get started with PySDK is by using AI hub inferences, which you can access simply by using @cloud for your host address. AI hub inferences open an HTTP or WebSocket connection to our compute farm, and they run inferences on whatever hardware is needed for the given model. That is to say, you don't need to possess any of the AI accelerators you're actually inferencing on. All you need is an internet connection. That means you could use anything you want, be it a laptop, a Raspberry Pi, even a phone. It really doesn't matter. It's perfect for prototyping and testing out different models or AI accelerators. However, since your inputs and the inference results are being sent over the network, there is added latency. If you want to have this run anywhere while still being able to separate out compute and application logic, use an AI server. To set up an AI server, just use our Docker container. Make sure to map out the correct ports and assign a volume to the container if you want to use a local zoo. More on that later. The container will have all the runtimes you need pre-installed, providing a seamless plug-and-play experience. If you want to use an AI server, just input the IP address of said server for your hardware location within your codebase. Do note, however, if you are not using the default port 8778 or 8779, make sure to add the port within your IP address for your hardware location. AI servers really are great though. They let you separate out application logic from hardware management, give you near native level inference performance over a local network, and they allow multiple clients to seamlessly run inferences off of one central server. However, since you are still technically sending information over a network, it's not as fast as the next option. For native level performance, use @local for your hardware location. @local directly accesses the AI accelerator hardware on your local machine, meaning there's no added latency with any network transfers. It greatly simplifies deployment and lets you have the fastest speeds for whatever model is you're running. However, this does mean that every machine needs to have the proper runtimes installed, and all hardware is ultimately managed by the end user. But what are we even inferencing? Well, that's where AI models come in. The easiest way to run models using PySDK is to use the ones hosted on the AI Hub at hub.degirum.com. On the AI Hub, we already have over 1,000 precompiled models ready for you to use. These models all vary from segmentation to classification to object detection, and we have multiple models compiled for each different hardware target supported by PySDK. However, if you want to use your own models, you can do that too. All we need is a little bit of extra information just to make everything compatible. Firstly, you will need a model JSON, which just contains some configuration information as well as some metadata about the model in question. On top of that, we would also need the model binary file, which just contains the weights for whatever model it is you're running. Optionally, you can also include a label file, the file which maps out the output classes from the model to a human readable label for you to be able to use. You can also create your own custom postprocessor just by supplying a Python postprocessor file. To learn more about how to make one of those, check out docs.degirum.com. But even with all these models, we need somewhere to store them. That's where AI zoos come in. AI zoos greatly simplify model management, and they allow you to have one central place to load these models into applications. You can either have zoos on your local machine, an AI server, or on the AI Hub. When using an AI zoo on your local machine or an AI server, they're stored in a directory on whatever machine is hosting these. That's actually exactly why we mentioned mapping a volume to your AI server container earlier, because these models are now stored locally on that server. Or if you're running all this @local, these models are now stored locally on that machine. With DeGirum's AI Hub, you can actually store and retrieve models without needing any manual downloads or local management. All of your models are easily managed by the website at hub.degirum.com. And you can even add workspaces in order to add proper authentication and authorization for usage of these models. Plus, the AI Hub works beautifully with our cloud compiler. With the cloud compiler, just supply a PyTorch checkpoint file and select whatever hardware you want to compile your model for. Then, when the model is finished compiling, it's automatically uploaded to a zoo of your choosing. Then, you can use your newly uploaded model directly in your code. No need to add any extra downloads or anything like that. If you want to learn more, you can explore more of the user guide at docs.degirum.com.